Welcome to the DIY Honda Garage channel. The DTC P2122 indicates a low voltage condition in APP sensor A or throttle position sensor D, indicating potential issues with the throttle input to the engine control unit (ECU). This fault occurs when the signal from the accelerator pedal position (APP) sensor is deemed to fall below acceptable voltage thresholds as detected by the onboard diagnostic system. The APP sensor plays a critical role in the vehicle's performance by measuring the driver's accelerator input and sending the corresponding voltage signal to the powertrain control module (PCM) in real time. Located at the accelerator pedal assembly, the APP sensor ensures responsive acceleration and optimal engine performance. The Diagnostic Trouble Code is confirmed when the signal from the sensor shows less than 0.2 volts and is observed on the Honda Diagnostic System (HDS) during troubleshooting. Addressing this code includes following specific steps to accurately diagnose and resolve the underlying issues to ensure the vehicle operates safely and efficiently. DTC P2122 refers specifically to a malfunction involving the accelerator pedal position sensor A, also known as throttle position sensor D, where a low voltage condition is detected. The APP sensor is a vital component in the vehicle that informs the powertrain control module, or PCM, about the driver's acceleration input. This information helps the PCM determine the engine's throttle plate position and adjust fuel delivery for smooth operation. When the signal voltage to the PCM is registered as less than 0.2 volts, it triggers the DTC P2122. Located near the accelerator pedal assembly, the sensor works continuously to ensure that engine performance aligns with driver commands. Monitoring this voltage is critical for engine performance and emissions controls, and a persistent low signal can lead to compromised vehicle functionality. Several factors can contribute to the occurrence of DTC P2122. One primary cause is the failure of the accelerator pedal position sensor itself, where internal faults could lead to incorrect voltage output. Additionally, a shorted APS1 wire, which connects the APP sensor to the PCM, could cause an incorrect voltage reading, indicating a low signal back to the PCM. Open circuits within the wiring also represent a potential cause. If there are breaks or disconnections within the wiring harness connecting the APP sensor to the PCM, the voltage signal can drop below the predetermined threshold, triggering the DTC. Thorough checks along these lines are essential to isolate the issue accurately and ensure the correct electrical path is intact. When DTC P2122 is active, several symptoms may arise that drivers can notice. The most common indication is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue that needs attention. A driver may also experience poor throttle response, where the vehicle does not accelerate as expected, causing frustration and potential safety concerns. Intermittent engine performance issues can occur. The engine may hesitate or stall unexpectedly due to the inaccurate readings being sent to the PCM. Over time, these symptoms can lead to more significant problems if not addressed, disrupting the driving experience and potentially compromising safety on the road. The first troubleshooting step in diagnosing DTC P2122 begins by turning the vehicle to on mode, which activates the electronic systems without starting the engine. Next, using the Honda Diagnostic System (HDS), technicians should check the voltage output from the APP sensor, ensuring it meets the expected operational threshold. The specific test involves observing the current conditions against the defined parameters. Ideally, the voltage should hover around the approximate operational threshold. If the system confirms that the sensor's voltage is less than 0.2 volts, the failure condition can be marked as duplicated. However, If the voltage registers correctly, the system may not be malfunctioning at that moment, possibly indicating an intermittent failure that requires further inspection of wiring connections or sensor terminals. Moving to the second troubleshooting step, the technician must first turn the vehicle off completely. This ensures safety during electrical system manipulations. Next, the APP sensor 6P connector should be disconnected to allow for accurate voltage measurements without interference from the sensor itself. Once disconnected, the vehicle is turned back to on mode, and the technician is tasked with measuring the voltage between designated test points on the APP sensor connector. Specifically, voltage should be tested between pins 4 and 5 of the APP sensor 6P connector. The technician expects to see a reading of approximately 5.0 volts under these conditions, confirming that the primary power supply to the sensor circuit is operational. If the reading does not meet expectations, further investigation into possible wiring issues will be required. In the third troubleshooting step, the focus shifts to checking for a short in the APS1 wire, which connects the APP sensor to the PCM. To begin, the vehicle is turned off, allowing technicians to work safely. The next step is to jump the SCS line using the HDS, which is a way of entering special service functions in the diagnostic tool. The connector on PCM-A 51P is then disconnected, allowing the technician to perform continuity checks between specific test points. This assessment involves comparing test point 6 on the APP sensor to body ground to identify any shorts. If continuity is confirmed, the APS1 wire is deemed shorted, necessitating repairs along this connection. If there's no continuity, there's no short, and further steps are required to isolate the problem. The fourth step in this troubleshooting process involves checking for an open circuit in the APS1 wire. Following the proper safety protocols, the technician will connect terminals A and B using a jumper wire, establishing a temporary link from the APP sensor connector to body ground. This step is crucial as it allows for a clear continuity test to be conducted with other critical components not connected. The technician will once again measure continuity between test points, in this case, from the PCM connector to body ground. If continuity exists, it indicates the APS1 wire is intact, thus guiding the technician to the outset of the issue. However, if an open circuit is measurable, the wiring will need debugging along its path between the APP sensor and the PCM, which could be the source of the low voltage reading. In the fifth troubleshooting step, the technician turns their attention to examining the internal circuit of the PCM, especially if previous continuity tests have confirmed the wiring's integrity. Initially, the jumper wire from the APP sensor 6P connector should be removed, and the PCM connector A 51P needs to be reconnected. Then, the technician will connect the jumper wire from pin 4 of the APP sensor 6P connector to pin 6, allowing the voltage for testing signals to flow through the designated passage accurately. With the vehicle in on mode, the readings available via the HDS will help determine whether the voltage from the sensor remains below the required threshold of 0.2 volts. If the readings indicate it is still low, the technician must either update the PCM software to the latest version or substitute with a known good PCM before re-evaluating. If after these adjustments, the DTC P2122 disappears, the diagnostic process will conclude. Otherwise, replacing the APP sensor will be necessary. The final troubleshooting step centers on assessing the VCC4 line for any potential open circuits. Initially, the vehicle should be turned off and the SCS line needs to be jumped as established in earlier steps. Following that, the PCM connector A must be disconnected to facilitate unimpeded tests. The technician will utilize a jumper wire to connect Terminal 4 of the APP sensor's 6P connector to body ground, creating a pathway for voltage checks. Continuity tests will involve checking the wiring from the PCM's connector A back to body ground, ensuring there's a complete and functional circuit. If continuity is confirmed here, it suggests the VCC4 wire is operational. As previously practiced, if there are issues with continuity, further repairs will be required to the wiring between the PCM and the APP sensor to rectify the low voltage reading presented by the DTC P2122. After completing all necessary repairs and component replacements, it's vital to conduct final verification of the repair process concerning DTC P2122. This begins with a thorough retest using the Honda Diagnostic System HDS to assess whether the repairs have resolved the issue. The technician should closely monitor voltage outputs from the APP sensor, ensuring that they now meet the specified operational parameters. Additionally, it is crucial to clear any previously logged DTCs and recheck the vehicle under various driving conditions, ensuring that the DTC P2122 does not reappear. A successful follow-up test confirms that repair work has effectively addressed the low voltage issue present in the APP sensor circuit, leading to optimized vehicle performance and stability. To prevent the recurrence of DTC P2122 and related issues, engaging in regular preventive maintenance practices is essential. One of the most effective methods is to routinely inspect wiring and connectors related to the APP sensor and PCM for signs of wear, corrosion, or loose connections, as these can lead to faults that might trigger diagnostic trouble codes. Additionally, keeping the PCM software updated ensures the vehicle operates under the latest specifications provided by manufacturers, which can rectify minor bugs and glitches that affect performance. Moreover, monitoring the performance of the APP sensor during routine diagnostic checks can identify early signs of developing issues before they escalate, contributing significantly to the vehicle's overall reliability. In conclusion, addressing DTC P2122 in the Honda Fit involves a systematic approach focusing on accurate diagnosis and thorough testing of critical components. Each troubleshooting step plays a vital role in identifying whether the APP sensor, wiring, or PCM is at fault. Diligently following the specified steps leads to a clear understanding of the underlying issues, allowing for effective repairs to restore normal performance. Regular maintenance and vigilant monitoring of electrical systems contribute to long-term reliability and optimal vehicle operation, safeguarding against sudden issues over time. Ultimately, a successful resolution of DTC P2122 not only enhances performance, but also instills confidence in the overall functionality of the vehicle. Please like and subscribe to the channel. See you next time.